In this video, we're going to focus on solving simultaneous equations or system of equations using the substitution method, the elimination method, graphing, and also systems with 3 variables. But let's start with a 2-variable system. So let's start with the elimination method. Let's say if we have the equations 2x plus y is equal to 4, and 2x minus y is equal to 0. So what can we do to solve for x and y using the elimination method? Now what you want to do is you want to add the equations in such a way that one of the variables cancel. We don't have to modify the equations in this example. If we add them, notice that the y variables cancel. Positive y plus negative y adds up to 0. So now we can add everything else. So 2x plus 2x is equal to 4x. And 4 plus 0 is 4. Now to solve for x, let's divide both sides by 4. So 4 divided by 4 is 1. Therefore x is equal to 1. Now that we have the value of x, we need to plug it into one of the original equations to solve for y. Let's use the first equation. So 2x plus y is equal to 4. Let's replace x with 1. So 2 plus y is equal to 4. Let's subtract both sides by 2. So we can see that y is equal to 4 minus 2, which is 2. So the answer, as an ordered pair, is 1, 2. Let's try another example using the elimination method. Let's try this example. 3x plus 2y is equal to 12. And 4x minus y is equal to 5. So feel free to try this example and pause the video, work it out, and when you're ready, you can unpause it to see the solution. So right now, if we add the 2 equations, none of the variables will cancel. 3x plus 4x is 7x, and 2y plus negative y is 1y. However, if we multiply the second equation by 2, the y variables will cancel. Positive 2y and negative 2y will cancel, but let's rewrite the equations that we have first. So the first equation is going to remain the same. 3x plus 2y is equal to 12. Now, if we multiply the second equation by 2, 2 times 4x will be 8x. 2 times negative y is negative 2y. And 2 times 5 is 10. Now we can add the 2 equations. So let's go ahead and do that. 3x plus 8x is equal to 11x. 2y and negative 2y, they will cancel. And 12 plus 10 is equal to 22. So now the next thing we need to do is divide both sides by 11. 22 divided by 11 is 2, so therefore x is equal to 2. So now let's use the first equation, and let's solve for y. So let's replace x with 2 in the first equation. So 3 times 2 plus 2y is equal to 12. And we know that 3 times 2 is 6. And in the next step, we're going to subtract both sides by 6. So 12 minus 6 is equal to 6. Next, we need to divide both sides by 2. And 6 divided by 2 is 3. So x is equal to 2 and y is equal to 3. So we can write the final answer as an ordered pair, 2, 3. This is it. Here's another problem. 5x minus 4y is equal to 21. And 3x plus 5y is equal to 20. So let's use the elimination method to solve it. So this time, we need to modify both equations. So let's cancel the y variable. What number should we multiply the first equation by? And what number should we multiply the second equation by? If you're not sure, you can find the least common multiple between 4 and 5, or you could just multiply 4 and 5, which is sometimes the least common multiple. 4 times 5 is 20, so let's get 20y. One has to be negative, the other has to be positive, so let's multiply the first equation by 5, because negative 4y times 5 is negative 20y. Now let's multiply the second equation by 4, because 5y times 4 is positive 20y. Now I need to multiply everything by 5 and 4, so the first equation is going to be 5 times 5x, which is 25x, and then 5 times negative 4y, that's negative 20y, and 5 times 21, 5 times 20 is 100, and 5 times 1 is 5, so 21 times 5 is 105. Now 4 times 3x is 12x, and 4 times 5y is positive 20y, and 4 times 20, 4 times 2 is 8, so 4 times 20 is 80. Now let's add the two equations. 25x and 12x adds up to 37x, and then negative 20y and 20y adds up to 0, and 105 plus 80 is 185. So now let's divide 185 by 37. And 185 divided by 37 is equal to 5, so x is 5. Now let's plug in 5 into the first equation. Actually, let's use the second equation. It might be easier, so let's replace x with 5, and let's solve for y. Now here's a harder example. Let's say if you have 2 over 3x plus 1 over 4y, let's say that's equal to 9. And if you have also 5 over 9x minus 5 over 6y, and let's say that's equal to negative 5. So if you have fractions, how can you use the elimination method to solve for x and y? Now what I would recommend doing is clearing away the fractions. You want to get rid of it. So let's look at the first equation. What is the common denominator between 3 and 4? The least common multiple of 3 and 4 is 12. If you use any other multiple than 12, like 12, 24, 36, it will still work. But the least common multiple is the one that's easier to deal with. So what you want to do first is you want to multiply everything by 12, just to clear away the fractions. So what is 12 times 2 over 3x? Or what is 12 times 2 over 3? 12 times 2 over 3 is the same as 2 over 3 times 12 over 1. Now there's two ways you can get the answer. You can multiply first and then divide, or you can divide first and then multiply. If the numbers are large, it's easier if you divide first to get a smaller number and then multiply. 12 times 2 is 24, and 24 divided by 3 is 8. Well, 12 divided by 3 is 4, 4 times 2 is 8, so either way you get the same answer. And then we'll have to add an x in front of it. So 2 over 3x times 12 is equal to 8x. Now what about 1/4 y times 12? 12 times 1/4 is the same as 12 divided by 4, which is 3. So this is going to be positive 3y. And now what is 12 times 9? 9 times 10 is 90, and 9 times 2 is 18. If you add 90 and 18, you're going to get 108. So 12 times 9 is 108. Now what should we multiply the second fraction by to get rid of all of the denominators? So we have a 9 and 6. What is the least common multiple of 9 and 6? Multiples of 6 are 6, 12, 18, 24, 30, 36. Multiples of 9 are 9, 18, 27, 36. So 36 is a multiple of 6 and 9. But is not the least common multiple. We could use it and we can still get the right answer. But it's easier if we use 18. That is the lowest common multiple between those two numbers. So let's multiply the second equation by 18. Now, what is 18 times 5 over 9x? Now, 18 times 5 is not a good number. I mean, it's a decent number, but it's not a fun number to multiply, right? But it's easier if you do 18 divided by 9. 18 divided by 9 is 2. 2 times 5 is 10. That's not bad, right? But if you do 18 times 5, you need to know that it's 90. 90 divided by 9 is 10. You get the same answer, but it's easier if you divide first and then multiply. So for the next one, 5 over 6 times 18 is the same as 18 divided by 6 times 5. 18 divided by 6 is 3. 3 times 5 is 15. And the last one, 5 times 18. 5 times 10 is 50. 5 times 8 is 40. You add them, you get 90. But it's going to be negative 90. At this point, we can't add the two equations because the x or the y variables won't cancel. However, we could multiply the first equation by 5. If we do so, we're going to get positive 15y, which can cancel with the negative 15y. So let's do that. So we don't need this equation anymore. So let's make some space. Let's move this up. 8x times 5 is 40x, and 5 times 3y is 15y. Now what's 108 times 5? 5 times 100 is 500, and 8 times 5 is 40, so 108 times 5 must be 540. And let's rewrite the second equation right below the first equation. Let's add them. So these two cancel. 40x plus 10x is 50x, and 540 minus 90 is 450. So now let's divide both sides by 50. So what is 450 divided by 50? Well, first you can cancel at 0. So 45 divided by 5 is 9. And so that's the value of x. Now that we know what the value of x is, we can find y. So let's use the first equation that we have. So let's replace x with 9, and let's solve for y. So 8 times 9 is 72. And what is 108 minus 72? Let's subtract it by hand. 8 minus 2 is 6. And 10 minus 7 is 3. So you get 36. So 3y is equal to 36. And now let's divide both sides by 3. So 36 divided by 3 is 12. So we have the 0.9 comma 12. That's the answer for this particular equation.
It's caught in the crossfire. It's caught in the crossfire.